All right. So for example 2, we are getting started and we want to find an explicit equation for each of these. That means you want to find, this is on page 311. And so f of x is equal to 1 over x plus 3. And now we have to plug in a 1 over x plus 3 wherever there is an x in g of x. And notice in g of x here, you have x's in 2 different places. Whatever you throw into g of x gets squared, and then you subtract 4 times whatever you put in. So g of 1 over x plus 3 is going to equal, well, whatever you put in gets squared, and then you subtract 4 times that. Now, if we simplified this and simplified it to a single fraction, what this is equal to is this is 1 over x plus 3 all squared minus 4 over x plus 3. How would I put those two fractions together? I'd need a common denominator. So I'd have to multiply this by x plus 3 and this by x plus 3. And if we did that, we will have a common denominator. So I'll have 1 minus 4x minus 12 all over x plus 3 squared, which is negative 4x minus 11 over x plus 3 squared. What is the domain of this composite function? Are there any non-permissible values? So it can't equal negative 3. Anything else not allowed? No, we have no square roots, so we don't have to worry about that. So x can be everything except x can't equal negative 3. For part B, the explicit equation is f of g of x. Well, g of x is x squared minus 4x. And in f of x, whatever you put in, that function says you do 1 over that plus 3. So if you put in x squared minus 4x, it's going to equal 1 over that plus 3, which is x squared minus 4x plus 3. What is the domain of that? Is there any non-permissible values? X can't equal 1 or 3. How did you know that? You would have to factor the bottom. X plus 1, oops, x minus 1, x minus 3. So the domain is everything but x can't equal 1 and x can't equal 3. So the one you can do for practice is 6, and we're going to do 6D together right now. So I'm going to get you to do a head start. So turn to number 6D. So again, what we're doing here in 6 is we are finding an explicit equation and then stating the domain. All right, let's see how you did. Did you do this first? Plugged in f of x inside, and then wherever there's an x, we now have to replace it with 1 over x minus 1. So this is going to be equal 1 over x minus 1 minus 1. So now you have a fraction inside of a fraction, and you have to simplify that. In order to simplify that, what we need to do is get a fraction on top and a fraction on the bottom. Then if you have a fraction divided by a fraction, you can multiply by the reciprocal. So on the bottom, can you see that this is over 1? And if I wanted to put those two together, I would need a common denominator. Again, use some space in between so you don't mix things up. I like to have a nice long line for my middle of my fraction. And on the bottom of my fraction, I'm going to have 1 minus x minus 1 all over x minus 1. Notice that I kept that x minus 1 in brackets because you're subtracting all of this. So that negative is going to get distributed to the x and to the 1. So this is going to become 1 over 2 minus x over x minus 1. And the top you can think of as a fraction as 1 over 1. Can you see you now have one fraction on the top, one fraction on the bottom, so you can multiply by the reciprocal. And you get x minus 1 over 2 minus x. So what's our domain? X can't equal 2, and x, in the simplified version, x can't equal 2. But in the entire process, right at the beginning, here you're dividing by x minus 1. In the initial question, you're dividing by x minus 1. Okay? So x can also not equal 1. Think of it this way. Remember the little boy putting numbers into the machine and the number came out and went into the other machine and so on and so forth? So we have two machines here. Both of these machines are f of x. If you throw a 1 into the first machine, it gets broken. Because the first machine is 1 over x minus 1. If you throw a 1 into that machine, it gets broken. Does that make sense? The second machine is still f of x. If you throw a 2 into the first machine, what's going to come out? If you throw a 2 into the first machine, a 1's going to come out. And when that 1 goes into the machine again, it's going to break it. So we have a problem that x can't equal 2 or x can't equal 1. Because either way, you're going to have that composite function break. All right. But if we just looked at the simplified form of the function, if we just looked at the simplified form, yes, only 2 is non-permissible. 1 would be fine here if you just had the simplified version. But if you went back to the original part of the equation, 1 causes a problem as well. The 2 minus x comes from right here. What's 1 minus a negative 1? That's the same as 1 plus 1 gives you 2. And then the minus times the x would give you the minus x.